During the test drive of the 10-question flag quiz, we showed you that when we made an incorrect selection, the flag would shake back and forth left and right. So to demonstrate that to you before we take a look at how to define an animation, I've brought up the app here in my AVD, and currently displayed on the screen is the flag for the country Aruba. So I'm going to purposely select an incorrect answer, so watch the flag as I click Cuba here, and you can see it bounce back and forth on the screen. I'll do it again for Mexico, and you see that kind of animation go back and forth, and then finally when I select Aruba, that's correct, and we move on to the next flag in the quiz. Now, going back over here to our Package Explorer inside of Eclipse, you can see within the res folder we have an anim subfolder, and when I created a new Android XML file and selected animation, it automatically created that anim folder for me and placed the file that I was creating into that folder. Now, by default, when you create an animation, it selects as the root element of the XML file the so-called set element for defining what's known as an animation set. And what this allows you to do is to create several different types of animations and apply them all at once to an element, in our case the image view that contains the flag. Now, before we get into the details of this particular animation set, I just want to pull up the documentation for animation resources, and you can see that we have two key categories of animations in Android. We have property animation, which is the topic of our Spot On game in chapter 8, and then we have view animations as well, and we're going to use in this example a so-called view animation. And within view animations are a couple of categories of animations. We'll be using what are known as tweened animations. And a tween animation basically allows you to define how some aspect of a view is animated, and then the system figures out how to actually perform the animation for you. That's called interpolation. So if you take a look at the set object, you'll see that there's several different kinds of animations. We have alpha animations, which changes the alpha value on a view, so that you can have a view go from opaque to transparent or transparent to opaque, and thus do fade-ins and fade-outs. We have scaling animations, which allow us to change the size of an object. Translation animations, which is what we'll use here to move an object on the screen, and also rotation animations to rotate objects on the screen as well. Now, these animations change the visual appearance of an item on the screen, but for example, if I move something using a translate animation, let's say that item is a button. If I move a button from the upper left corner of the screen to the lower right corner of the screen using a view animation, only the appearance of the button moves. If you tried to click that button or touch that button as a user in the bottom right corner after the animation, it wouldn't do anything. But if you still touched the upper left corner where the button originated, that would actually allow you to get that touch event. So with property animations, you can actually move buttons on the screen and still have them function correctly. And in fact, we're going to do something like that with our Spot On game app again in lesson 8. Now, going back to our particular animation for this example, we have an animation set in which we define 3 translate animations. And a translate animation allows you to move an object on the screen. And you can see here for each of the translate animations we've specified some properties. The Android from X delta property says that we want to move from an X delta of 0, meaning start from the item's original location. We want to change to an X delta of minus 5% P, which means I want to go to the left, the minus sign means left, 5% of the width of the parent element, which is going to be the layout in which our image view appears. And we want the duration of that animation to be 100 milliseconds. Now again, normally when you have an animation set, all of the animations within the set are performed in parallel. But you'll see here on lines 9 and 10 that this next translate animation has a start offset property of 100, which means it doesn't actually start executing until 100 milliseconds after the animation set starts executing. And therefore, because the first animation takes 100 milliseconds, this one will start as the first animation ends. And similarly, this last translate animation will start 200 milliseconds into the future, which means it will start after the second animation ends. Now, in the second translate element, you can see that it's from x delta is from the starting point of the previous animation's finish. Or its starting point is the previous animation's finish. Its 2x delta is 5% of the parent, which means move to the right to be 5% of the width of the parent. Then we have a duration of 100 milliseconds, and again the starting offset. And then finally, the last animation starts from 5% of the width of the parent to the right, goes to minus 5% of the width of the parent to the left, and again takes a duration of 100 milliseconds, starting 200 milliseconds after the animation set starts executing. You'll also notice that we've specified a so-called Android interpolator here for the set, and it's a decelerate interpolator, which means that each animation starts off fast and slows down over its duration. And there's actually lots of different interpolators that you can choose from. And in fact, I'll just go back to the documentation for the animations we were looking at, and there's a table that shows you all the different interpolation values. And I must have scrolled right past it. There we go. So here's the set of interpolators. These are the actual classes defined in Android for interpolators, and these are the resource IDs that allow you to use the different types of interpolators. So for example, a linear interpolator will move the object during a translate animation at a linear speed, a fixed speed over the duration of the animation from one point to another. And you can experiment with the different interpolators that you see here to see how it affects, for example, our flag shake animation if you would like. Now, when we get into the actual source code for the flag quiz game app in the Java file, we'll see how we load up this animation and apply it to our image view.